Okay, let's do an integral with the either cylindrical or spherical. And it's always a question which one you should choose. And so this question is kind of going over that basically. So the bounds are x plus y squared plus z squared equal to z, and below that and above this cone right there. So there's a cone that looks like this. Let's first of all figure it out in the Cartesian. And so there's a cone like that sitting there, and then this shape. So this was the cone, and that shape looks like, to know the shape, do the completing the squares, and so you get x squared plus y squared plus z minus 1/2 to power 2 equal to 1/4. That's a completing the square. Check that out. And so basically it's half of it's piece of a sphere on top of that. And there's a point 1/2 is the center of the sphere, and the radius 1/2, if you see z equal to 1/2 on the z-axis is the center of the sphere. You can figure out what this the radius of this circle is, but we're basically finding the volume of the ice cream cone. And a scoop on top of it. So what is how do we do this? First of all, we have to convert everything to spherical. See what is becoming of them. Z equal to square root of x squared plus y squared. And the first one is just x squared plus y squared is r squared. And this one again, yes, because it's the upper part of the cone, so it's z equal to r again. Now, if I'm kind of comparing these things, I have basically I have an r and I have if I just imagine that you're kind of giving a slice or giving a cross section in whatever direction of theta you have. So you end up with a cross section looking like this. So a cross section that has a little bit piece of the cone right there, and then you have the ice cream sitting on top of it. And so if I want to do this in terms of, let's say if I want to do this in terms of R being the most inner, I can see R is basically going from different values to different values, right? And so there is the blue piece and there is the red piece right there. So I'm gonna not go with the R, but go with the Z direction inside. So I'm gonna go with the Z direction, the most inner. Okay. So Z direction seems like always going from the cone to the ice cream, and that is consistent, and that makes my life a lot easier. Here's the thing, so this is the cone and that's the ice cream, and so ice cream I have to solve in terms of z. How do I solve in terms of z? So this is actually a quadratic equation in terms of z. So when I'm solving, it's going to be negative b, which is 1, plus minus square root of 1 minus times the negative sign plus 4r squared divided by 2. Negative value doesn't work for z, so z is going to be 1 plus the square root of 1 plus 4r squared divided by 2. Oh, I see I made a teensy error right there. This is supposed to be negative sign. Negative. Right there, a negative sign. Okay, so that said, I have the ice cream with this equation and the cone with that equation. So my most inner, let's say dz, goes from r to 1 plus square root of 1 minus 4r squared divided by 2. And then I have to figure out the rest of them. Maybe figure out dr next, and d theta is pretty easy, right? D theta, because both shapes are going all around, is going to be from 0 to 2 pi. But what about r? And what else am I forgetting? Don't forget your Jacobian right there. So don't forget your Jacobian. And you're finding the volume, so the function, the integrand is going to be 1. So it's 1 times the Jacobian. Now let's figure out what r is. Here, how do I know r? R is this the biggest length you can get in there. And I have to go about and intersect these two equations to find r, intersect. And r squared plus z squared equal to c, z equal to r, and this gives you 2r squared equal to r, and that is 2r squared minus r equal to 0, r equal to 0, or r equal to 1/2, and that's the 1/2 that I want, so r goes from 0 to 1/2. So that was the setup. This is the final product of the setup for the cylindrical coordinates. Yes, and next thing is to find the next thing that you want to do is to find the spherical coordinates for this. Shape, we've done it already. That's the ice cream cone. Now, how do I set up that? And so first thing is you convert again. That is, this side is just going to be rho squared. This side is going to be rho cosine of phi. And then you have z equal to square root of x squared plus y squared. And that is, if I replace the left side, rho cosine of phi, the right side, it's going to be rho squared cosine squared theta sine squared phi plus rho squared sine squared theta times sine squared phi. If you factor out sine squared theta and sine squared phi, then you end up with cosine of, what is left is cosine squared theta plus sine squared theta. So that's equal to 1. So this is basically square root of rho squared sine squared phi, which is rho sine of phi. Now simplify this and you get rho cosine of phi equal to rho sine of phi. And that is, if rho is not 0, then that means cosine of phi should be equal to sine of phi. That is, tan of phi should be equal to 1. And phi, I know that phi is only going to be equal to the maximum that it gets is in the first quadrant. And so that would be phi equal to pi fourth. Okay, so I got phi equal to pi fourth, and what else do I know? Let's look at the shape, the ice cream cone again. What we have is the cone right here, and then ice cream on top. When rho travels, rho starts from 0 and radially it gets out. And so basically starts from 0 and goes to the ice cream itself. So rho starts from 0. Oh, what is the ice cream? Ice cream is this value. And so let's simplify that. And that is rho. I can write, if rho is not equal to 0, then rho has to be equal to cosine of phi. And so it goes from 0 to cosine of phi, the rho. And then phi starts from 0 very top right there and goes to the cone, 0 to pi fourth for phi. And then theta goes from 0 to 2 pi. Okay, what am I forgetting? Very important, I'm forgetting the Jacobian. And so this is the setup. And so some people prefer the cylindrical there, or some people prefer the spherical down here. And both of them are okay if they let you choose. I do prefer the spherical for this one. But also the cylindrical is not that complicated unless you make it complicated and make it into two regions.